Okay, so hopefully you're happy with 3A on arithmetic sequences. We're now moving on to arithmetic series. Just to remind you, the sequence is where we've just got the list of numbers and you can look at the nth term in the sequence. The series is where we start adding the terms together. So one of my favourite things, little stories in maths, is about the sum to n of the arithmetic series and the formula for it, and it's credited to Johann Gauss in 1777 to 1855, and as a young boy, 10-year-old, apparently sat in class with his maths teacher trying to buy some time, told the whole class, right, just add up the numbers please from 1 to 100. And a minute or so later he looks up and he says to young Gauss, Gauss, why are you not working? And he says, oh, well, I've got the answer, sir. It's 5,050, which was, of course, correct. And apparently, so one way that he could have done this, let's have a look. A very, very smart way of doing it, we can have a look at 1 plus 2 plus 3 plus all the way up to plus 100. We're going to write it out again here, 100, but backwards, 99 plus 98 plus all the way down to 1. Now, if we add these up, we can see that that pair adds up to 101. This pair adds up to 101, as does this pair, as does this final pair. So what have we got here? We've actually got 100 lots of 101, which is 10,100, but we've added up that twice. So divide that by 2 and we get our 5,050. Very, very neat, very quick answer. And the reason I love this as well is that if you remember this method, this is actually how we do the formal proof in a more general way as well. So coming on formal proof then. So my formula that you need to know is this, okay? And what we've got here is how we're writing it out. So the formal proof could be an exam question, okay? We can start by writing the sum to n. We're going to use that notation, s to n. That's my first term. My second term is a plus d. My third term, a plus 2d, all the way up to my nth term, a plus n minus 1d. I then write it out again, but backwards. So I'm starting with my nth term, and then I go all the way down to my third, second, first term here. When I add these up, look what happens. I'm going to add that. That's my equivalent of 1 plus 100, okay, my first and my last terms. And here I get 2a plus n minus 1d. And here, if I do that right at the end here, add these up, again I get the same thing, 2a plus n minus 1d. Just to convince you that I would get that on each of them, my second term written here is a plus d. And my term written here would be not a plus n minus 1d, but it would be a plus n minus 2d. Well, if I expand these out, I'm going to get 2a plus d plus nd minus 2d. And here I'm going to have, that would simplify to 2a plus nd minus d, or 2a plus n minus 1d. Okay, so what I've got then is I've got that n times, and then the final part, divide by 2, gives me my formula. Now you need to know that formula, you need to learn it, n over 2 times 2a plus n minus 1d. Okay, and you've got the nth term formula in your head already, a plus n minus 1d, and this is just n over 2 and then 2a plus n minus 1d. So there is an alternative formula, which is basically n over 2 times a plus l, where l is the last term. You can go through and you can work out the same kind of thinking, and this is often easier to use. You need to know both. It depends on the information we're given as to which of these formulae you're going to use. Okay, so we're going to look at answering some of these questions. Find the sum to 30, sum of the first 30 terms of these arithmetic sequences. Start off by writing your formula. We're asked for the sum to 30, right? Sum to n equals n over 2 times 2a plus n minus 1d. I would recommend that you write this out every time you're using it in these questions. It will help you to learn it and memorize it. Here we're then going to write what the information we know. So a equals 2, d equals 3, and we're looking for sum to 30. We're looking for n equals 30. Quite simply plug that into the formula. So plugging it into the formula showing exactly what a, d and n are, and writing it out, that's where you're getting your marks, and then evaluate. You get 1, 3, 6, 5 for that one. Same thing in part 2, in question 2. Write the formula out. So sum to n is n over 2 times 2a plus n minus 1d. Then write down what a, d and n are. Write your formula again, plugging those values in. And then evaluate. Gives you 2,130 for question 2. And exactly the same again for question 3. Write your formula, write down what a, d and n are. By writing it down, a is p. My common difference here, I'm adding p each time, so d is equal to p and n is 30. By writing the formula and what a, d and n are, you are less likely to make mistakes, and then you can just plug it in to find your sum to 30. So 30 over 2 times 2p plus 29p, simplify that, gives us 15 times 31p, and our final answer then 465p. Next question here, find the least number of terms for the sum to exceed 2000. So start off by writing a statement of what we're looking for. We are looking for the sum to n to be greater than 2000. That's my question. I want to find out what n is. So I can start off by writing my formula for my sum to n. By the time you've written it this many times, you will know it off by heart. Greater than 2000. And then make a note of a is 4, d is 5, we don't know n. Okay, that's what we're trying to work out. Plug a and d in and see what we get. We get that, then simplify that, multiply up by 2, rearrange, and we get our quadratic inequality. You can use your calculator to solve that, and we get the answers like so. Now we know that n has to be an integer because we're talking about the position, the nth term. So, and also n must be positive. So n must equal 28 here. Look at the positive one. N equals 28. Check we've answered the question. Find the least number of terms for it to exceed 2000. We must add together the first 28 terms. Okay, so here's quite a typical exam question on these sequences and series, and actually the entire question here can be answered just from using these two formulae, okay, the nth term formula and the sum to n. What I really recommend is pause the video, read it through, maybe give it a go yourself, or unpause it when you need a bit of help. Okay. Okay, the first thing that I would do is I would start writing out what this sequence looks like. So year 1, year 2 and so on. So in scheme 1 we get P in the first year, P plus 2T in second year, P plus 40 in year 3, and so on. Now have a look at scheme 2 and do a similar thing. So we've got P plus 1800 in our first year, P plus 1800 plus T in year 2, P plus 1800 plus 2T in year 3, and so on. So we want total earned under salary scheme 1 for the 10-year period. So here we are looking at finding the sum to 10 of our scheme 1. Start off by writing our formula n over 2, 2a plus n minus 1d. Okay, here write n equals 10, a equals p, and d equals 2t. Plug that in. 10 over 2 times 2p plus n minus 1 is 9 times 2t. Simplify that. And that takes us to what we were trying to show. Okay, next part. For the 10-year period, the total earned is the same for both salary schemes. Right, we're going to have to do exactly the same thing for salary scheme 2. This is where it's helpful to have written down my first term there, P plus 1800, and to see clearly that my common difference is T. Okay, plug that into our formula. And we find that this is our total amount for the 10-year period from the salary scheme 2. We're told that these two things are equal. And so putting those equal, we can see that 45t must equal 18,000, and we can work out from that t must be 400. Last part, for this value of t, the salary in year 10 is this. So we are looking at the 10th term, un is a plus n minus 1d for salary scheme 2. So my 10th term there, 29850 is equal to A in scheme 2. That's P plus 1800 plus n minus 1, we're talking year 10, so it's 9D. And my D here for salary scheme 2 was T, so 9T. We're told what T is, we've just worked out what T is, so we can plug that in and we can solve it, and that gives us that P equals 24,450. Okay, have a go now at exercise 3b. You can skip some of the earlier questions or do just a selection of them, but make sure you get through to the exam style questions as well.